everyone. Today we are going to take lecture on DBMS and our topic is SQL RDBMS concepts and databases. Here we see in our outlines. Today we are covered in our lecture. So let's start with index. Index is used to create and retrieve data from the database very quickly. Index can be created by using single or group of columns in a table. When index is created, it is assigned a row ID for each row before it sorts out the data. Proper indexes are good for performance in large databases, but you need to be careful while creating index. Selection of fields depends on what you are using in your SQL queries. Say for example, see here the table customers. We are creating a number of field ID, name, age, address, salary. Here we are creating 5 columns in customers table. Data integrity. Following categories of the data integrity exist in RDBMS. First is entity integrity. Entity integrity is all about there are no duplicate rows in a table. Domain integrity. Domain integrity is about enforces valid entries for a given column by restricting the type, the format, or the range of values. Referential integrity. Referential integrity is about rows cannot be deleted which are used by the other records. User defined integrity. User defined integrity is about enforces some specific business rules that do not fall into entity, domain, or referential integrity. Now we are discuss about anomalies. Before that we are actually taking the little bit concept of normalization. Now what is normalization and why we need normalization? Then normalization is a process of organizing the data in database to avoid data redundancy, insertion anomaly, update anomaly, and delete anomaly. Now we are actually discuss about what is anomalies. The anomalies in DBMS, there is in 3 types of anomalies that occur when the database is not normalized. These are due to the insertion, due to update, and due to deletion. Now here we see insert anomaly. Due to user insert any record, whenever the data is going to be in an inconsistent mode, it is actually considered as an insertion anomalies. Whenever user has need to update the particular record, and due to that, if our data is going to be in an inconsistent way, then it is considered as an update anomalies. And delete anomalies, whenever user want to delete a specific record and still due to that impact the database tables is not actually going to be in an inconsistent mode, then it is considered as an deletion anomalies. Let's take an example of anomalies. Now here seen that we have 4 columns: employee ID, employee name, employee address, employee department with the number of values. Here the table is not normalized. We will see the problem that we face when a table is not normalized due to the insert, update and delete anomalies. Suppose a manufacturing company stores the employee details in a table. Here we seen the name employee that has four attributes as we discuss employee ID for storing employee's ID, employee name for storing employee's name, employee address for storing employee's address, and employee department for storing the department details in which the employee works. At some point of time, the table looks like here we see the table with the number of records. Now update anomalies. In the in our table, we have two rows of employee Rick as he belongs to two departments of the company. If we want to update the address of Rick, then we have to update the same in two rows of the table. Will become inconsistent if somehow the correct address gets updated in one department but not in other, then as per the database Rick would be having two different addresses, which is not correct and would lead to inconsistent data. It is the update anomalies. Now insert anomalies. Suppose a new employee join the company who is under training and currently not assigned to any department, then we would not be able to insert the data into the table if employee underscore department field does not allow nulls. It is the insert anomalies. And delete anomalies. Suppose if at a point of time the company closes the department D890, then deleting the row that are having employee department as D890 would also delete the information of employee Maggie since she is assigned only to this department. So it is the anomalies due to the number of reasons the data is going to be in a inconsistent mode. So to overcome these anomalies, we need to normalize the data in so that database normalization. As we are seen in the previous slide, there is a number of reasons are there by which our database is going to be in an inconsistent mode. To overcome this problem, we need to normalize our database. Now, database normalization is the process of efficiently organizing data in a database. There are two reasons of the normalization process. First is eliminate eliminating redundant data. For example, sorting the same data in more than one table. And second one, ensuring data dependencies make sense. Both of these are worthly goals as they reduce the amount of space a database consumes and ensure that data is logically stored. Normalization consists of a series of guidelines that help guide you in creating a good database structure. Normalization guidelines are divided into normal forms. Think of forms as the format or the way a database structure is laid out. The aim of normal form is to organize the database structure so that it complies with the rules of first normal form, then second normal form, and finally third normal form. Has also another normal forms, but here we are actually covered the three normal forms of database. Now first normal form sets the very basic rules of an organized database. There is a set of rules are there. First, define the data item required because they become the columns in a table. Place related data items in a table. Second, ensure that there are no repeating groups of data. Third, ensure that there is a primary key. Now, here we see in the first rule of normalization, we ensure that they become a column in a table. For that, place related data items in a table. Now, second rule of 1NF. In the first NF, uh, you must define the data item. This means looking at the data to be stored, organizing the data into columns, define what type of data each column contains, and finally putting related columns into their own table. For example, you put all the columns relating to locations of meetings in the location table, those relating to members in the member details table, and so on. Second rule of 1NF, it is the next step is ensuring that there are no repeating groups of data. Now consider the tables. Here we've seen that customer tables with number of fields, ID, name, age, address, and orders. So if we populate this table for a single customer having multiple orders, then it would be something as follows. Seen that there is a number of records which is inserted into a particular table. But if but as for 1NF, we need to ensure that there are no repeating groups of data. So here we seen that number of records which is actually considered as an in repetitive groups. Due to the anomalies, the database is actually going to be in an inconsistent way if you want to insert, update, or delete any records. So we need to break the table into two parts. See that customer tables contain ID, name, age, and address, and the values of this table is look like in following records. See that there is an only one data in this table, and we are creating another table orders. Here we actually split our actual table into two tables for no repeating groups. If we are seeing the values in first table, then so many repetitive values are there. For that, it is actually the lack of second rule of one normal form. Here we actually divide our table into two table to remove the repetitive groups. First we are actually creating the tables and the values are as declared here, and the second is order table. Here we are actually creating the order table with the id, customer id and orders. Here we see the values of table. Now the basic image over here that okay, due to the anomalies our database is actually going to be in an inconsistent mode. Now whenever we actually divided our table into two tables, there is no anomalies is actually impact on our table. It is a normal form of 1NF. Still we have actually lots of problem in our table, but whenever we actually normalize our table into number of forms, then we are actually reducing whatever the problems is present in our table. Now the third rule of 1NF is the final rule of the first normal form. Create a primary key for each table. When we have already created, seen in our first table, we already create the primary keys. ID is considered as an primary key in customer table. And here in order table, ID is also considered as an primary key. Now second normal form. Second normal form states that it should meet all the rules of 1NF and there must be no partial dependencies of any of the callouts on the primary key. Consider, say for example, consider a customer order relation and you want to store customer ID, customer name, order ID and other detail and the data of and the date of purchase. See the table. This table is in first normal form in that it obeys all the rules of first normal form. In this table, the primary key consists of customer ID and order ID combined. They are unique, assuming same customer would hardly order same thing. However, the table is not in second normal form because there are partial dependencies of primary keys and columns. Customer name is dependent on customer ID and there's no real link between a customer's name and what he purchased. Order detail and purchase date are also dependent on order ID, but they are not dependent on customer ID because there's no link between a customer ID and an order detail or their sale date. To make this table complete with second normal forms, you need to separate the columns into three tables. See the example. First, create a table to store the customer detail as seen that. First, create customer table with the field customer ID and customer name varchar, and customer ID is declared as a primary key. Next, create a table to store detail of each order. First is actually contain the information about customer and the next table is actually contain the information about orders. See the order tables, we are actually creating the field order ID that is actually considered as a primary key and order detail. And finally create a third table storing just customer ID and order ID. It is actually the main focus is to keep track of all the orders of for a customer. Here we seen in the customer orders table, customer ID and order ID. It is with the combination. It is working as a primary key and sell date. So here we actually achieve the rules which is defined by second normal forms. Third normal form, a table is in third normal form when the following conditions are met. It is in second normal form and all non-primary fields are dependent on the primary key. That is the need for the third normal form. The dependency of non-primary field is between the data. For example, see the table street name, city and state are unbreakably bound to the zip code. Here we seen that street, city, state. It is actually depending on the zip. It is not actually depending on the customer ID. In this table, we actually creating the customer ID as a primary key, and our third normal rule is all non-primary fields are dependent on the primary key. Here we seen that this table is actually considered as a lack of the rules of third normal forms. So we need to take or break our table into number of tables. For that, here we seen that the dependency between the zip code and address is called a transitive dependencies because of number of fields is actually depending on the zip, and finally the zip is actually depending on the customer IDs. So between the zip code and address, the relationship is exist. It is actually considered as a transitive dependency. To comply with the third normal form, all you need to do is move the street, city and state field into their own table, which you can call the zip code table. Here we see in the example, first we are actually creating the table address separately. So it is actually contain the number of field zip, street, city and state. Here we actually taking the zip as an primary key because of state, city and street is actually depending on zip. And next we are alter the customer table as follow. See the customer table with number of fields, customer ID, customer name, date of birth, zip, email ID, and here the customer ID is actually considered as a primary key. Now seeing that we are actually achieving all the rules which is actually required to make our table into third normal forms. Here in a customer table, every field which is actually depending on a primary key. Here the advantage of removing the transitive dependencies are mainly twofold. First, the amount of data duplication is reduced and therefore your database becomes smaller. The second advantage is data integrity. When duplicate data changes, there's a big risk of updating only some there's a big risk of updating only some of the data, especially it is spread out in a number of different places in the database. For example, if the address and the zip code data were stored in 3 or 4 different tables, then any changes in zip code would need to ripped out to every record in those 3 or 4 tables. Now, we have seen that SQL RDBMS databases. There are actually many popular RDBMS available to work with. Here, the number of databases are there. First is MySQL. MySQL is an open source SQL database which is developed by Swedish company MySQL AB. MySQL is supporting many different platforms including Microsoft Windows, the major Linux distributions, Unix and Mac OS X. MySQL has free and paid version depending on its usage, non-commercial or commercial, and its feature. MySQL comes with a very fast multi-thread, multi-user and robust SQL database server. MySQL Server. MySQL Server is a relational database developed by Microsoft. Its primary query languages are TSQL and ANSI SQL. Now the TSQL is transaction SQL. It is a set of programming extension from Sybase and Microsoft that add several features to the structure query language, including transaction control, exception and error handling, row processing and declare variables. SQL is a structure query language which is a common database language for all RDBMS product. Different RDBMS product vendors have developed their own database language by extending SQL for their own RDBMS product. TSQL stands for Transaction Structure Query Language, which is a Microsoft product and it is an extension of SQL language. And here the example of TSQL is MS SQL Server, SQL, TSQL and Oracle SQL PLSQL. And ANSI SQL, still we have seen that the ANSI is actually stand for American National Standard Institute. SQL is built such that its syntax are simple and language almost similar to English language. You will be able to get an idea by reading the query that what the query does. These different versions of ANSI SQL, each of them support the general command like select, create, update and insert. There is a lot of advantages of ANSI SQL. Execute queries on database, create new database or table in database, drop or delete, create table from the database, insert and retrieve data from database, update the records in the database, create store procedure, create views in database and set permission on table, views or procedures. As everyone is know about Oracle, it is a very large and multi-user database management system. Oracle is a relational database management system developed by Oracle Corporation. Oracle works for efficiently manage its resource, a database of information among the multiple clients requesting and sending data in the network. It is an excellent database server choice for client server computing. Oracle support all major operating systems for both client and server, including MS-DOT, NetWare, Unixware, OS2, and most Unix flavor. MS Access. This is one of the most popular Microsoft product. Microsoft Access is an entry-level database management software. MS Access database is not only an inexpensive but also powerful database for small scale projects. MS Access uses the JET database engine, which utilizes a specific SQL language dialect, sometimes referred to as an JET SQL. MS Access comes with the professional edition of MS Office packages. So, hope you enjoy. Thank you.